Alright guys, this is Ms. Kissinger and welcome to section 6.3, proving that a quadrilateral is a parallelogram. Now, we already learned about the different properties, which says if it is a parallelogram, then something. Now we're going to do the converse of all of these things. So if something, then the quadrilateral is a parallelogram. The first one we're going to talk about is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, what I'm going to do is use this fancy program called Geometry Sketchpad, and I'm going to construct two random length segments. And I'm going to give them midpoints so I know right where the halfway point is. And I'm going to take these points and I'm going to stick them directly on top of each other. Okay, so now I have two lines that are bisect each other. So now I'm going to connect my endpoints and give myself some outside line segments. Now, what I'm going to do is I'm going to show you that if I measure each of these links, okay, that is human error. That's why they are off by 0.01 centimeter. But if I measure each of these links, they're all going to be pretty darn close to the same thing, which proves to me that if this line is congruent to this line, and this one is congruent to this one, then I'm halfway to a parallelogram. The last thing I need to know is slope. So I'm going to measure the slope of all of these lines. So DE has a negative 0.22 slope. BC, which should be parallel, has a negative 0.22 slope. DB has a negative 4.15, and EC should also be negative 0.415, which again, human error. I'm really sorry, I couldn't get it exact. But this proves that if I have two diagonal lines that bisect each other perfectly, then all of these lines should have the characteristics of a quadrilateral. Now, when I first did this one, I can show you that it did come out perfect. I don't know why I couldn't do it the second time, but this is a perfect quadrilateral. Notice that MN is the same length as OP, and NO is the same length as PM. Then we have the slope of NO, which is negative 0.18, which should be the same as the slope of MP, which is true, and OP has the slope of negative 3.2, which is the slope of NM. So there you have it. The theorem has been proven using Geometry Sketchpad. Okay, let's go back to the PowerPoint or the notebook. And the next theorem says, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So how I'm going to prove that is I am going to make two lines, or one line, and I am going to copy it. And if I copy this line and paste it, it will have the exact same slope and the exact same length. Now I'm going to set it over here. Now if I connect my two endpoints of each one, then it should make a perfect parallelogram. So the measure of that is 8.1. The measure of that one is 8.1. I don't know why it named it AA and BB. Then the measure of this line should be the same as the measure of this line, which is true. Now the last thing I have to test is all my slopes. My slope is negative 0.22. This slope here, again, negative 0.22. This slope is negative 4.54. And again, this one should be the same. 0.454. So this proves to you that if I have two parallel congruent segments, then I can have a quadrilateral that is a parallelogram no matter what. Alright, back to our theorems. Our next theorem says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in Geometry Sketchpad, I'm going to make two segments that are the same. Two sets of segments that are the same. So I have this segment. I'm going to copy and paste them. Now, if I try to hook them all together, they should all hook together perfectly and make a parallelogram. Now, I won't do all the other stuff because I think I've proven my point, but that is what that theorem does. And finally, we are to our last theorem, is that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And what I'm going to do is on the next slide, we are going to flip, and we are going to talk about that right here. Alright, I'm going to move this out of the way a little bit. But now, a quadrilateral, the total degrees of a quadrilateral is 360 degrees. So I'm going to say 360 is equal to x plus y plus x plus y. Now the reason I can say this is because since this angle has one mark and this angle has one mark, then they are both x, and same for these ones, so this is y. So now I have 360 equals 2x plus 2y. Now I'm going to divide everything by 2. So I have 360 divided by 2, which is 180 degrees, is equal to 2 divided by 2 is 1, so we have x plus y. Now, the reason that this is equal to 180 degrees is because we learned yesterday that if we have consecutive angles, then consecutive angles add up to 180 degrees in a parallelogram. So it is enough to know that the opposite angles are congruent. So then we have our theorem, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this proves our last theorem that we saw over here. Now, on your homework tomorrow, or on Monday, we're going to be doing problems that look like this. So it's going to say, can we determine if it is a parallelogram? So this first one, we see that this angle is marked with 2, and this angle is marked with 1, and then over here we have an angle marked with 2 and an angle marked with 1. And then we know that these two are obviously congruent. So this angle here is congruent to this one, and this one is congruent to this one, meaning that our opposite angles are congruent, which means we have a parallelogram no matter what. So yes, this is a parallelogram. Now this next one, we need to know that our opposite sides are congruent. Now opposite means across, remember? So if we have one angle that has one tick mark, or one side that has one tick mark, and the other side has 2 tick marks, then that means our opposite sides aren't congruent, which means no, this cannot be a parallelogram. Moving to this one. Now, I know one side is parallel, one set of sides is parallel, and since they are both marked with x, then I know each side has the same value. Whatever that value is, it is the same. So, I have one set of parallel and congruent sides, which is one of our theorems, so yes, this is a parallelogram. And lastly, the theorem that we know that has to do with diagonals says that our diagonals bisect each other, which means this line here should be cut directly in half by this line. So if I have 1 tick mark and 2 tick marks, then that means this is not congruent to this, which means no, this cannot be a parallelogram. Now, if I had it to where this was like this. So if my tick mark was like that, and this tick mark was like that, then yes, it would be a parallelogram. But since it was the other way around, it does not work as a parallelogram. Now, I hope you wrote down those theorems because when you're doing your homework in class, you're going to want all of those in order to do problems like this. Have a great weekend, and you're welcome for a short video.